Welcome to this presentation on Inspections Overview. My name is Neil Potter and I will be your instructor. If you have any questions about any information covered in this presentation, please use the question and comment box located on gogo.com. The topics we're going to cover in this module are where can inspections help, who uses inspections, and a comparison to reviews and walkthroughs. If you're on a project and you're building an output, a requirements document, a design document, a user guide, piece of code, you probably have a hard time predicting the level of quality of the final result. So one way to use inspection is to sample the work and find how good it is, get a defect level, and use that data to predict the final quality. It's not perfect, but it gives you a very rapid way to understand where you are today and what is likely to come up. If you're in a project and it has many problems right now, you're stuck in test, a lot of rework, and test cycles, you could use inspection to clean up the work and reduce the defect level and the rework level and get a final solution better than it was before. A quicker way to operate and get a better result. Products are late to market. There are many reasons for products being late to market. The delays can be caused by status issues, dependencies, and defects. So for the defect type of issues, you may have a requirement spec that is poor, is difficult to test against, difficult to interpret. So inspection could be used to clean up the requirements and make them easier and quicker to use downstream. You may have code stuck in test, and inspection will be a quicker way to find defects in the code and save some of the testing cycles you have to go through. So where there is a quality cause to the delay, inspection can help you either find the defects earlier or quicker than you may be today. Maintenance costs are high. Anytime you have a legacy product out there that has defects and problems, the rework costs go up. So the better we can get the quality of the output, the less we're going to have on effort required to maintain those products. Current walkthroughs or reviews not effective. You may be doing something now that helps you find mistakes, but you may not be happy with the efficiency or effectiveness of those reviews. So we'll discuss how inspections can be used alongside with and to help improve the performance of walkthroughs and reviews. And standards not being met. You may have standards defined now for coding, for requirements, documents, for user guides, for plans that are not being met. Inspection is a way to utilize those standards, make them more concise, and use them to clarify if the work is actually meeting the standard or not. So what is inspection? Inspection is an efficient and economical method of finding defects or potential defects in products and processes early in the cycle. How about inspection as a feedback mechanism? In this diagram, on the left is the product start. On the top right is the goal. The goal is a working project, a working product or a solution in the hands of the customer and they're happy. To begin with, we may collect the requirements. But if we collect the wrong requirements, or ambiguous requirements, or there are some major mistakes in the requirements definition, if we were to go implement those requirements and follow that first path to the end, you can see we'll be a long way away from the goal. So inspection is a way to get feedback on the requirements definition and take corrective action. If you were to go through the design phase or a prototyping phase, then if you took the second path for too long, you would miss the goal completely. So inspection is a way to get feedback on that phase also and take corrective action. So we may never hit the ideal path, but for sure we can take corrective action and avoid these major tangents that could occur by not having feedback on our work. How about some characteristics of inspections? On the top right is the output of a project, a plan, design, code, requirements, test plan, other documents like user guides. On the top left are the steps used to create that product. They could be formal or informal process steps you go through day by day to build those outputs. So on the right hand side we inspect, we end up with a defect list, and we take a rework. Now we could leave it just like that, and that will be adequate for inspection. Later in the class we'll discuss causal analysis, where we take some of the defects, typically the most common or most severe, we take some specific lessons learned based upon their root causes and improve the process steps so we end up with less chance of making those type of mistakes. So there is a way to build a feedback loop into the cycle, which we'll discuss towards the end of the class. So who uses inspection? Well, inspection came out of IBM and the engineering industry back in the 70s. And typically engineers on the left are the primary users of inspection. They do coding, they use it for test procedures, requirements documents, design, test cases, and other documents like user guides. So engineers typically use inspection to find defects and feedback in their work. I have myself taken inspection to managers. They have plans, policies, and contracts. And because the documents, inspection applies well to those. On the bottom, technical writers that do tech pubs and user guides and help text, they typically have a hard time getting feedback on their work, and they can use inspection too to provide a level of feedback and thoroughness before they go to release. I've even taken it to administrators that do cost accounting, forecast documents, balance sheets, and procedures, and have had them find defects in their work too, in a rapid kind of way. In the middle we have document changes. Any process document you may have, you could use inspection to find defects and mistakes in those too. So where do inspections fit in? Here's a project flow. You can fill in the phase names that you typically go through in your project. You could apply inspection to the output of each phase. You get a list of errors, they get reworked, and those errors don't go through the next phase because they get found earlier. You may decide that you want to do 100% of inspection, that every major output that you care about is inspected for defects. But you may not have enough time allocated in the schedule for that. So you could sample. You can pick a sample, 1, 2, 3% of that major output, determine how good it is, and see if it's good enough or clean enough to go to the next phase. If it is not, you could then dramatically upgrade the sample and do a higher coverage. So in inspection, don't feel like you're constrained or you must inspect everything or nothing. You really can choose per phase the degree to which you inspect. So where do inspections fit in? Here's a common cycle: plan, do, check and act that projects use to plan their work. If I'm doing Scrum, I may have a sprint, a phase or a 2 to 4 week phase of a project. I plan the work, I do the work, I check the results at the end, I act upon the results. If I'm doing a phase of a project, like a requirements phase, I plan the phase, I do the phase, I check the phase at the end, and take corrective action upon the results. So inspection is a way to check the work, check the phase as being complete. So we can then define a task complete, like requirements or design or code, as the work has been inspected, reworked, and at an acceptable defect level. And we can define that level based upon historical data when we collect that data. So we may decide per 100 lines of code, per module, per feature, per use case, per user story, per page, to have a particular number of defects that we expect to find, and the work should be at least as good as that. So inspection is a way to define done for a particular phase of a project. This inspection process came initially out of Michael Fagan and IBM and his colleagues back in the early 70s. We picked it up from Tom Gilb, and Tom Gilb is an independent consultant that still teaches the method today. And then we picked it up and modified it a little bit based upon Tom's input. But pretty much we teach the Tom Guild process. So there are other ones out there that all have a little different flavour, look and feel. But if you were ever to explain what process you are learning here, it will be kind of a Tom Guild, or based upon Tom Guild's work. Now, how does it compare to reviews, walkthroughs? Well, typically a review is a generic term that covers management and technical activities. You have a status review, you have a design review, you provide the audience with information or evaluate conformance to specs and plans, and they give you feedback. A walkthrough, typically technical in nature, explain and discuss the product and find defects. And the defects are found because of the discussion you have and the explanation. An inspection is typically more narrowly focused, and here we're not discussing or explaining the product, we're just detecting and identifying defects. So, more efficient, more focused activity. But it applies for all three. So you use all three when you keep the objectives separate. If I'm at the beginning of a project and I want to discuss some ideas with colleagues or status them, I may do a review or walkthrough. If I believe I am done with that phase, then I may hold an inspection to kind of show or verify I'm done with the phase by finding defects and assessing its level of quality. So if we keep the objectives separate, then we have a very good use for all three activities. Let's look at a context example. We have a phase, maybe called requirements. We go through a technical review or walkthrough with the ideas with our peers. They give us feedback and ways to do the work better. We refine the idea. We go through maybe a optional second review or walkthrough. But when we believe we are done with that phase, we then hold an inspection. An inspection then clarifies for sure the defects that are left and how done we really are. And we rework based upon that data. Now, if you have done walkthroughs or any kind of meeting before, you will know this scenario is pretty common. The team meets, the author is there a little defensive, and he says his work is perfect, and the audience become attackers and they get their darts out and they start throwing. So one thing we've added to inspection is some ground rules for how the team should behave so they avoid this particular kind of scenario. And a little later on we'll discuss the techniques we include in inspection to do that. Let's look at a comparison between a walkthrough and inspection. So a walkthrough is typically a generic term, typically focused on improving the product. That could be any kind of work product. Explains logic and flow of the product, finds defects because of this discussion and the feedback, and typically examines alternative solutions. So it's very beneficial to hash out an approach to doing something and getting feedback from your colleagues and use their expertise. Typically 2 to 7 people in the team, typically no moderator or facilitator trained. The quality can be variable, the preparation not always done. Team shows up, not prepared. They kind of do their best given where they are today. Personalities can get in the way. Nobody there to train, control, facilitate, or moderate the personalities. And therefore not always efficient and can waste time. Now on the right hand side we have inspection. Primarily we define the steps, making them clearer, define some standards and checklists that can be used, define mistakes, defects. We add a trained moderator, that is you in this case, you're being trained as a moderator, and then we add some simple metrics to understand how well it went. Now anything above this line will be a basic addition to a walkthrough to make it into an inspection. Anything below the line is more advanced and could be considered optional for inspection. We could create a statistics database to record and store the data. We could actually longer term adopt simple statistical control to filter the data, understand really kind of what it's telling us, what is noise, and what is the essence of the inspection result. But that will be a far more detailed analysis than we will discuss in the class. And these three things at the top primarily give us an inspection process based upon our initial walkthrough definition. So how does it compare to other methods in its ability to find mistakes? Well, here's a qualitative definition first. We have some data and numbers coming out later on. But on the left-hand side, nothing. People just don't do anything to find defects, and obviously very poor. The second one, routing among peers. So the team writes some code or a design, they send it as an attachment to their colleagues, and they may or may not have time to look at it, and they give some level of feedback. But you really have no idea what time they spent, how thorough it was, and even if they understood what you had given them. So very poor at being able to find defects. Walkthroughs and reviews straddle the line between cross fingers, or hoping, and cost effective. There are some teams out there that do very good walkthroughs and very good reviews, and they're a very effective use of people's time. And other ones that are obviously not. Testing and inspection, I think they are adequately well measured to understand the effort required to do them and the result of doing them. On the right hand side we have formal verification. Formal verification is like a mathematical proof of the code to really kind of show that that function is actually being performed correctly. It will be good for life critical or very critical kind of systems, typically more expensive than we want to spend on most projects. So why would we use inspection? Well, the first thing, defects are identified. So we get to clean up the work. And that identification process, just doing it, just finding defects and becoming aware of those, will train the people to make less defects. It's this kind of a secondary effect of inspection. If you are told continually what mistakes you have made in a nice way, then you will start to kind of learn how to avoid those mistakes and make less mistakes. The teamwork is a secondary side effect. We're not going to specifically work on teamwork in the class. We're going to work on the skills that teams can use to find defects and avoid the negative comments, the being defensive, and the tangents. Those give better teamwork when they're practiced. And if you care about standards and want people to have standards that they really like to use, that really contain the issues that they care about, then inspection can be used to do that too. If you have questions or comments about the information covered in this presentation, please use the question and comment box located on gogo.com.